Hello everybody and welcome to this Dev TV entitled Registry Free Inventor Add-ins. My name is Philippe Lifma and I'm working for Autodesk Developer Network. Today I'm going to take you through those three main topics, the first one being the mechanism of the Registry Free Add-ins, how it works and how to create a Registry Free Add-in for Inventor. The second one is the migration. I will explain to you how you can easily convert an existing registry-based add-in to a registry-free add-in. Either it is .NET or a C++ add-in. And then in the third topic, I will explain to you how you can deploy your registry-free add-in to a target client machine, and as well expose some consideration about the new Exchange store for Inventor that allows you to put your application online. So let's start with the first topic, the registry-free add-in mechanism. The registration-free COM mechanism is provided by Microsoft since the Windows XP Service Pack 2 and higher version of Windows like Vista and 7. This mechanism provides several advantages, the main one being the fact that a COM component that is registry-free is being loaded within the scope of the application loading it. This will, for example, prevent some version conflict between a shared COM library on the same target system. Since 2012 release of Inventor, the registry-free COM add-ins are now supported. Using the registry-free COM add-in mechanism is the recommended approach, and if you create an add-in project from scratch, it will be very straightforward because the wizard provided with the developer tools will create a registry-free add-in by default. So let's take a look at what are the various components of a registry-free add-in. The first thing is the .addin file, that is an XML-like file, and that defines the various settings that used to be stored in the registry. The .addin file is placed in a certain directory that is monitored by Inventor during startup and is referencing the path of the compiled add-in DLL on the system. The add-in DLL can be placed anywhere on the target machine as long as the path is correct inside the .addin file. Then a manifest file needs to be embedded inside the add-in DLL during a post-build step at compile time. So let's take a look at how a classic .addin file looks like. The first thing we can see here is the class ID and the client ID, which are the same and that are set to the GUID of our COM component. We then get the display name and the description. Those are the fields that will be visible to the user inside the Inventor Add-in Manager. Then the assembly tag specifies the location of the add-in DLL. So this path can be defined absolutely, or it can be defined relatively to the location of the .addin file. We have other classic tags you may know, like the load on startup, user unloadable, supported software version, and so on. Those are classic fields that were used to be written in the registry. And then we can notice the apparition of a new tag as well, the OS type, that can be set to Win64 or Win32, depending if you want your add-in to be loaded on a 32 or 64 platform. If you wish your add-in to be loaded anyway of the platform, you can just remove this tag and the add-in will be loaded for any platform type. Another functionality available not in 2012 but in Inventor 2013 and higher releases is the ability to create some localized .addin file. You can see in the example below that I created some display name in English using the code 1033, and as well I created the display name in French using the code 1036. So depending on which language version will be used in Inventor 2013, the user will be able to see either the display name in French or in English. Here are the various locations that will be scanned by Inventor during startup in order to browse for .addin file and try to load add-ins. We can see that we have 4 various locations depending on how we want to load the add-in concerning the Inventor version. The first one is the version independent, so the .addin file which are placed in this directory will be loaded by any version of Inventor. The version dependent directory is specific to a certain version of Inventor. Here we can see that the directory is reference for Inventor 2012, so if we want to load our add-in in Inventor 2013, we will need to place the .addin file in the Inventor 13 directory. We've got as well a per user override that will allow us to load some specific settings depending on which user is running Inventor. And then fourth location has been created for loading application plugins for various Autodesk applications installed from the App Store. As I mentioned previously, the project created by the add-in template for Inventor are now creating Registry Free Add-ins by default. The installation of those templates is very straightforward. You can just copy simply the 2 zip files into your Visual Studio template, project template location, depending whether you are running a Windows XP or a Windows 7 or Vista machine. Those locations are slightly different. You don't need to unzip the file, but you actually just need to place that file in those locations. And when running the new project window from Visual Studio, you will see that the add-in template is automatically available. So let me illustrate that through a demonstration of add-in creation. Alright, so I've got Visual Studio running and I'm going to create a new add-in project. I'm going to select Visual Basic, for example, and you can see here is my template that appears if I install the zip file into my Visual Studio project template directory. I'm going to simply change the name of my add-in and going to call it Inventor Add-in VB Test. Creating the solution. Okay, so the first thing you can notice is that the COM registration region has disappeared, so the code is actually smaller. The only thing I'm going to modify in the code is to place a message box over there so I can see when my add-in is actually loaded. Let's take a look at the properties of my project. First of all, we can see here that the COM component is not registered for COM interrupt, so that means that there is no information written in the registry. And if we take a look at the build event, we can see here the post-build steps that have been created by the wizard. The first step created by the wizard is the invocation of the empty executable that will allow the compiler to embed the manifest file inside the add-in DLL during that post-build step. The second thing automatically generated by the wizard is that line of code that will automatically copy the .addin file into the right location. So Inventor 2012 in this case will be able to load the add-in during startup. Other thing created automatically during the generation of the project by the wizard are the .addin file. You can see here that the fields are populated by the wizard, and as well the path of our add-in DLL has been set automatically to the output of the project. So obviously, if I now move my project to another location on my disk, I will need to update manually this path, but as long as I let the project where I created it, this will work. The other thing is that the manifest file as well has been generated automatically by the wizard. So I can just now compile my add-in. You can see that the build is succeeded. And when loading Inventor, I will hopefully see that my add-in is getting loaded. Here we are. Another interesting functionality is the fact that after cleaning my project, automatically Visual Studio will remove the .addin file that has been copied, so this will unregister my add-in. For those of you using the Visual Studio Express Edition, you have to be aware of a couple of limitations comparing with the Visual Studio Professional. The first thing is that the Post-Buld step functionality is not available under Express, so you will have to perform manually the steps I described previously. You can as well store those steps in a batch file in order to run that file once your add-in has been compiled. The after clean functionality as well is not available, so you will have to manually delete the .addin file if you want to unregister your add-in. The other thing is that upon creation of a new project, all the files are created on a temp folder. You will have to call the save all command, and you will have to update the location of the directory you selected inside the .addin file. If you wish to get some more advanced information about the Registry Free COM component, please refer to the following MSDN URLs. Let's talk now about the migration of existing COM-based add-in to the Registry Free format. The first thing is to remove the COM visibility. So for .NET, you will need to delete the register and unregister methods from your add-in. The add-in GUID property is in the same region as those register and unregister function. So if you intend on using this property in other areas of your add-in, for example, while creating user interface ribbons, you want to be careful and not to delete that property. As well, you will need to uncheck the Register for COM Interrupt checkbox inside the Compile tab of the Application Properties dialog. Concerning the C++ add-ins, you need to remove the code associating with registering the add-in in the registry. For that, you can simply delete the RGS file associated with the project, remove the DLL register server and DLL unregister function. You then need to uncheck the Register for COM Interrupt checkbox on the Build tab of the Application Properties, and finally remove the Post-Buld step that register the add-in located in the Build Event section of your settings. You can clear out any text in the command line field as illustrated below. The second step is to create the manifest file. Create a new file in the same directory as your project and name it using the name of your add-in x.manifest, where the add-in name will be replaced with the name of your add-in. The name attribute of the CLR class element consists of 3 parts separated by dots. The name has to be formed as follows: assembly.namespace.addin server class name you used in your project. To make sure of that, you can retrieve the assembly name and root namespace from the project property as illustrated in the screenshot below. Here is an example of how my manifest file looks like, and you can see in yellow are the fields that need to be edited specifically for your add-in. The step 3 is the creation of a .addin file. So you can create a .addin file based on an existing one, and you can just replace the fields that are highlighted in yellow depending on your project properties. The fourth step is to embed the manifest file and set up the Post-Buld step in our project. So for .NET, you can edit the Post-Buld step through the Visual Studio properties, and you can just copy those lines into your project, changing the name in yellow according to your project properties. You can as well manually edit the VBproj or VCproj file in order to set up this after clean step that will automatically delete the .addin file from the location and then unregister your add-in. Concerning C++, the first two settings are the part of the linker. Settings and the value to change are highlighted in the picture below and concern the manifest file and the user account control that has to be set to no. Next setting is the manifest tool settings. Make sure that the embed manifest setting is set to yes and that the output manifest file is set to the correct file. The last step is to copy the .addin file into the folder of your choice, depending on the Inventor version or the user override you want to use. Okay, so let's see now how we can create an installer in order to deploy our Registry Free add-in to a client machine, and as well some information about creating a package ready to be uploaded onto the Exchange store online. So as we seen previously, the .addin file has to be copied to a specific location on the machine. However, the add-in DLL and support file can be placed anywhere in the system, and you probably want to let the user choose that location during the install process. So you may wonder how you can handle this feature, as the .addin file has to be updated with the correct location of the DLL that is obviously known only during the install time. The answer to that is to create some custom logic inside our installer class that will take care about updating the .addin file assembly tag with the correct location of the DLL that is chosen during the install. So you can see here a small screenshot of the code handling that functionality. So this is based using the XML API in .NET, and I will show you this code in more detail during the demo. So in order to easily add this functionality to your project, I created a template available in C# and VB.NET that will gather all those logic for you. So the only thing you will need to do is to add a new item to your project based on that template. In order to install the template, this is again pretty straightforward, as you simply need to copy those zip files into the following Visual Studio item templates directory. So let's see how it works through the demo. So let's get back to our add-in project I created previously, and I'm going to add a new item to this project based on my item template. So this is my RegFree add-in installer template. I'm just gonna create a new class of that template, and here is the code for that class. We can see that I would require two new references to my project. The first one being the system XML and the second one being the system configuration install. Here we go, system configuration, and system XML has been added to my project. I can now compile again that project and I can see the build is successful. So let's quickly have a look in more detail at the content of that installer class. We can see that the class derived from the installer class provided by the .NET Framework. And here are the install and uninstall overrides procedure that will be called by the MSI when the installer is run on the client platform. I don't want to go through the details of this code, but here is the install registry free method, and we can quickly have a look at it. And what this method is doing is editing the .addin file in order to update the assembly tag with the right location of our addin DLL. So the next thing we want to do is create a setup project in order to generate our MSI. So I'm going to add a new project to my solution, choosing an Visual Studio installer. I'm simply gonna call it setup VB. So the first thing I need to set in my installer is the custom action in order to set the output. I'm gonna add inside the application folder a new output and select the primary output from my addin VB test. That's alright, and I'm gonna as well add a custom action for the uninstall, selecting this same primary output. The next thing I want to do is exclude that Inventor Interop DLL. I don't need to install that along my addin. This will be already installed as a part of the Inventor installation. And I then want to include the addin file as well as I install my addin DLL. So I can simply add a new file to my application folder, and that file is going to be my .addin file present in my project. So when doing this, the .addin file will be installed along with the addin DLL, and then my installer logic will take care about updating this .addin file and copying this .addin file to the right location. So let me build that installer. And I will now clean my project so the .addin file installed by my project will not conflict with my installer. Alright, so last thing I need to do is simply test my installer. So I'm gonna run this MSI. You can see here I didn't set any property inside my installer, so default company name is still displayed, but I can anyway choose those default settings. It will anyway take a bit of time in order to create those entries inside the Windows system. But the installation is complete, and hopefully when running Inventor I should see my addin dialog being displayed. Yeah, and you can see it just works. So the last thing we wanted to talk about is how you can create hubs that can be placed online on the Inventor Exchange store. So the first thing you may wonder is, what is a valid hub for the store? Well, this might be multiple things. An Inventor add-in, obviously, but as well it could be some tutorial or documentation file, some library that correspond to an existing application, a standalone utility based on Apprentice, for example, or actually whatever set of file you want it to be. And we think about providing the ability to put web services, not now but in the future. So how do you prepare your add-in to be an app? First of all, the add-in must be registry free. Then it must be drag and drop ready. That means it must be conformed to the bundle format I'm going to talk in a second. It must have help files that illustrate how to use the application and that describes what the application is doing, an icon that can be placed on the store and in the Inventor App Manager, and as well a good description on your application that will be placed on the store for the users. Once you've got those information ready, the AddIn team will package your add-in into an installer that can be uploaded on the store. So let's see in more detail what is the exact content of a bundle. The following slide illustrates the content of a .bundle package. First of all, the name of the package has to follow the following scheme: company name, .product, .application name, .bundle. Inside that directory, you will need to create a folder named Contents that will contain any DLL related to the application and that are platform independent. As well, you will place at this location the .addin file. You may optionally create some Win32 and Win64 folders that will contain any platform-specific components and DLL. Then, a documentation folder will contain any help file and readmes you may provide with your application. Under this, a resources folder will contain any logo and icons you will need to use in the help file, the App Store or the App Manager. The submission process for the App Store is pretty straightforward. Send us an email to App Submissions and say you are interested in the App Store. We will send you the guidelines and some information you have to complete as requested. Develop an application suitable for the store, then send us the .bundle package to App Submissions. We will highlight some issues potentially that you have to fix, and then when the QA is ready, we will upload the package to the store. That's the end of this Registry Free Add-ins Dev TV. Thank you for attending it, and I wish you good luck in order to develop your next Inventor plugins.